Okay, so the technique you're going to use today is just an extension of yesterday. But the question that you're going to be asked before you complete the problems is the inequality always, sometimes, or never true? And I'm going to do an example of each. All right. So let's say we got negative 2 times 3x plus 1, and it's greater than negative 6x plus 7. So we're going to do the distributive property on the left side first. And negative 2 times 3x is negative 6x minus, and then we got negative 2 times 1 is negative 2, greater than negative 6x plus 7. Now, if you have the same value in front of a variable on both sides of the equation, you can add 6x to each side, or you can just cancel them out, whatever you feel more comfortable with. So this cancels, the negative 2 falls down, the greater than sign falls down, and we get a 7. So you ask yourself, is negative 2 greater than 7? No. So in this case, this inequality is never true. There is no solution. If you get to this step and the information is just incorrect, the values, they don't work. All right? That's no solution, and it's never true. Everybody okay with that? Yeah. All right. So then let's look at we got 5 times 2x minus 3 minus 7x less than or equal to 3x plus 8. So again, we're going to do the distributive property. So we get 10x minus 15 minus 7x less than or equal to 3x plus 8. If we combine the 10x and the negative 7x, we get 3x minus 15 is less than or equal to 3x plus 8. And then we've got a 3x on each side, right? So can't we just get rid of it? We can do this. And we're left with negative 15 is less than or equal to positive 8. So then you ask yourself, is negative 15 less than or equal to 8? Yeah. Negative 15 is less than or equal to 8, isn't it? Okay. Always. Isn't that always true? Isn't negative 15 always less than or equal to 8? Okay. So this would be an always situation. An always situation is infinite solutions. Any questions there? You see the difference between always and never? All right, in this case up top, -2 is always, or I'm sorry, -2 is never greater than 7. So it's just a never true. And -15 is always less than or equal to 8. So always true, infinite solutions. And then your third example will look like this. 9x plus 2 times 2 plus x less than 5 plus 9x. So over here on this left-hand side, this 9x falls down, and we got to distribute this +2. So this +2 times 2 is +4 plus 2x less than 5 plus 9x. If we combine the 9x and the 2x, we get 11x plus 4 less than 5 plus 9x. Can subtract 9x from each side. So 2x plus 4 is less than 5. Subtract 4 from each side. So 2x is less than 1. Divide both sides by 2. And we get an x that's less than 1/2. So this is a case where the equation is sometimes true. All right? And the equation is sometimes true, or the equation is true when you substitute anything into the equation that's less than 1/2. All right, so all of the problems you did yesterday had a solution, right? Everything you did yesterday had a solution. So all the equations that you solved yesterday were sometimes true. Sometimes they were true when you used a value, in this case, less than 1/2. So does that make sense to everybody? Does anybody not understand the difference between always, sometimes, and never? All right, when you get a regular answer like we did yesterday, that's sometimes true. When you get to this step in your problem, the x's have canceled out, and whatever you have left is true. All right, that's an always true. Doesn't matter what you substitute in for the x's, the equation will always be true. And then if you get to this step where the information left is never true, then there's no solution. The equation is never going to be true. Any questions? All right, then your practice for today is going to be on that same page 38 again. Problems 30 through 34. Obviously you're on a shortened period today, so if you get a chance, learn a few Alex topics. If not, maybe learn a few at home tonight. So.